Hello guys, welcome back to my YouTube channel. Today I am going to solve day 23 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 1438, longest continuous subarray with absolute difference less than or equal to limit. Okay, so in this problem we have given an array of integers nums and an integer limit. Okay, and we have to return the size of the longest non-empty subarray such that the absolute difference between any two elements of this subarray is less than or equal to the limit. Okay, so see this example one. Okay, nums array is like this 8247 and limit is 4. Okay, so uh, if I just take this 8 as my subarray, okay, then the max length that I am getting is 1. Okay, if I take this 8 and 2 as my subarray, okay, then see the absolute difference between the minimum and maximum element of this array. Okay, this subarray. So max element is 8 and minimum element is 2, right? 8 minus 2 is equal to 6 and 6 is greater than the value of my limit, right? My limit value is 4. Okay, so this is not a valid subarray. Okay, this is not a valid subarray. Okay, so definitely I don't have to treat this as a valid subarray. Okay, so now let's move forward. Okay, so now let's see this 2. Okay, if I just take this 2, then again the max length that I am going to get is 1, right? Because here my max element in this subarray is 2, my minimum element is also 2. Okay, then the difference between them is 0 and 0 is less than equal to my limit, right? So it is a valid, okay, it is valid subarray. Now if I just consider this 2 and 4, okay, so now what is the max element in this my subarray? 4. And what is the minimum element in my subarray? 2. Okay, so absolute difference between them is 2 and 2 is less than equal to my limit's value is 4. Yes, so this is a valid subarray. Okay, so now my max length becomes 2. Okay, so here I am writing my max length. So right now my max length becomes 2. Okay, so now let's suppose if I add 7 here, 2 4 7, I need the continuous subarray. Okay, note this point, I need the continuous subarray. Okay, longest continuous subarray, this is what I need. Okay, so if I had just consider this 2 4 7, then what is the max element in this subarray? 7 and minimum element is 2 and 7 minus 2 is equal to 5 and 5 is greater than my limit. Okay, 5 is greater than my limit, then that simply means that I don't need to consider this. Okay, so this is not a valid subarray. Okay, okay, so now let's take this example. Okay, if I just consider 4, then yeah, max element is 4, minimum element is also 4, difference is 0 and 0 is less than equal to limit. Okay, this is valid, length is 1, no issues. Now if I just consider this 4 and 7, then max element is 7, my minimum element is 4, 7 minus 4 is equal to 3 and 3 is less than equal to my limit, this is 4. So this is valid subarray 2. Okay, so again max length is 2. Okay, and I have covered all the possible subarrays. Okay, I have considered all the possible continuous subarrays. Okay, so see here output is 2. Okay, this is the max length that I am getting, right? This is the max absolute difference between two elements of the subarray, okay, which is less than or equal to the limit. Okay, so see, this is what explained here, right? 8 with the maximum difference, 8 minus 8 is equal to 0, 0 is less than equal to 4, 8 2, we don't need to consider this because the value absolute difference is greater than 4, we don't need to consider this actually. Okay, 8 to 4, because we already know that the difference between 8 and 2 is already greater than my limit. Okay, so we don't need to consider this. Okay, so I hope that you guys are clear with the explanation. Okay, so now let's move to the example 2. Okay, so this is my nums array and this is limit. Okay, so here from example 1, one thing is clear, that every time I am finding the max value, right, and I am finding the minimum value. Okay, and if the difference between my min and my max value, okay, absolute difference between them is less than equal to my limit, then in that case this is going to form a valid subarray. Okay, so let's suppose there is one array like this. Okay, there are some elements like 10 1 2 10 4 2 3 6 7 and here 2 2 and here 1. Okay, and let's say my limit value is uh, 10. Okay, let's say it is 10. Okay, so now in this case, what is the max element here? Max element in this array, max element is this 10. Okay, and what is the minimum element here? Minimum element is this one. Okay, so now if you just calculate the absolute difference between the max element and my minimum element, so you will find the answer as 9. Okay, and 9 is always less than equal to my limit value, right? Limit is 10. So definitely all these elements will have the difference always less than equal to my limit. Okay, because if the difference between max and minimum, because these are two only will form the maximum absolute difference, right? I will always find the maximum absolute difference between the max element and the smallest element. Okay, and all these elements lies in between these 1 and 10, right? So definitely the absolute difference between these elements, okay, in between will be less than 10 minus 1 is equal to 9. Okay, so let's say if I want to calculate difference between 10 and 4, it is 6. Okay, if I calculate difference between 10 and 2 is 8. Okay, because we already know that difference between the largest and smallest is always less than equal to my limit. So definitely this will form a valid subarray every time. Okay, so I hope that this line is clear. Okay, so every time we are finding the max value and we are finding the minimum value, and if the absolute difference between them is less than equal to my limit, then definitely this is going to be my valid subarray. Okay, so now let's understand this problem with example 2. Okay, so this is my array 10 1 2 4 7 2. Okay, so let me write it. 10 1 2, then 4 7 2, and limit is 5. Okay, 4 7 and 2. Okay, this is my array. Okay, and the limit value is given to me as 5. Okay, so see, every time I am making note of the max value and the min value, so definitely I have to use the heap na. I have to use the heap. Okay, so let's suppose, okay, let's suppose like this. Okay, let's suppose initially, let's suppose that I am here at this position. Okay, this is my left and this is my right. Okay, both my left and right pointer are here. Okay, so now my right moves to this position. Okay, initially if just 10 is there, okay, so 10 minus 10 difference is 0. Okay, 10 is the max and 10 is the minimum only. Okay, if I just consider this element, okay, then this is going to form one valid subarray. Okay, one valid subarray. Okay, so here I am updated the max length as 1. Okay, so now let's suppose my this r moves one step forward and my r reaches at this position. Okay, this is my right. Okay, so now in this the absolute difference between the minimum and maximum element is 9, right? And my value of this 9 is greater than my limit. Okay, is greater than my limit. Okay, so definitely this is not a good valid subarray. Okay, this is not the valid subarray, okay, which we need. Okay, so definitely I have to move my left to the next position. Okay, so definitely I have to move my left to the next position. Okay, so now instead of this I have moved my left to this pointer. Okay, that at this position. Okay, at this index, particular index. Okay, so now can I just consider this one? Yes, first time I have to check this one. Okay, this is the only array, let's suppose. Okay, this is the only array. Okay, this, so here max is 1, minimum is 1, 1 minus 1 is 0, and so again my max length remains 1. Okay, so now after that just move my right pointer to the next position. Okay, so my right moves to this position. Okay, so now 1 2, max is 2 and min is 1, so absolute difference is 1. 1 is my less than equal to limit, so definitely this is going to form a valid subarray. So let's update my max length to 2 here. Okay, 1 2, this is one valid subarray. Okay, so now again move my right pointer to the next position. Okay, move my right pointer to the next position. Okay, so now let's say my right reaches at this position. Okay, so now see this 1 2 4, max is 4, minimum element is 1. Okay, max is 4, minimum is 1, 4 minus 1 is 3, and 3 is less than equal to limit. Okay, so again update my max longest continuous subarray length to 3. Okay, this is one valid subarray. Okay, this is done. Now just move my right to the next position. Okay, just move my right to the next position. So now my right reaches at this position. Okay, right reaches this position. Now see this array. Okay, my max element is 7, my min element is 1, and the absolute difference between them is 6, and 6 is greater than my limit. Okay, so this is not a valid subarray. So now what I need to do? So here I need to move my left to the next position. Okay, I need to move my left to the next position. So now my left reaches here. Okay, now my left reaches here at this position. Okay, so now yeah, when my left reaches to the next position, so do I need to find the max and min element again? Okay, every time I am finding the max and min elements now, so again I have to find the max and min element. Okay, that's what I don't need to do. Okay, because if I do this, okay, every time in a part of this subarray, if I just calculate min and max again and again, then it is going to increase my time complexity. Okay, then it is going to increase my time complexity if every time I am going to search for the minimum and max element in that particular subarray. Okay, so that is why I come to conclusion that I need to use the heap. Okay, I need to use the priority queue. Okay, and I need to maintain both minimum and max elements. I need to obtain both minimum and max elements. So I have to use the two priority queues. Okay, one is for max heap and one is for min heap. Okay, that is the reason I am going to use min heap and max heap. Okay, so that is the only reason, because I don't want to search again and again my max element and my min element in a particular subarray again and again. Okay, so now let's complete this first dry run. Okay, so now in this part, what is my max element? 7, and my minimum element is 2. 7 minus 2 is 5, and 5 is less than equal to my 5. So this is one valid subarray. Okay, so now my right is going to move forward. Okay, so now my right reaches to this position here. Okay, now see in this part, so my minimum is 2 and my max is 7. Again difference is 5, and 5 is less than equal to my limit. Okay, so I have to update my max this length to 4 this time. Okay, and this 4 is my output here, right? 4 is my output. 2 4 7 2 is the longest, since the maximum absolute difference is 2 minus 7 is equal to 5. 5 is less than equal to 5. Okay, so here in this dry run I showed you guys why we need to use min heap and max heap. Okay, so now I am going to show how my min heap and max heap is going to work in this particular example. Okay, so now see carefully. What is my array? 10 1 2 4 7 2. Okay, so let me write my array. Okay, so my first element is 10, then 1, then 2, then 4, then 7, and then 2. Okay, so let me double check. 10 1 2 4 7 2, and my limit is 5. Okay, my limit value is 5. Okay, so I have to use min heap and max heap. Okay, so let me draw here. Let's suppose this is my min heap, and this sky blue color box is my max heap. Okay, so here let me write. So this is my min heap. Okay, and this is my max heap. Okay, max heap. Okay, and let me write the indexes as well. Okay, so this is a 0th index, this is 1 index, this is 2 index, this is 3 index, this is 4 index, and this is 5 index. Okay, so first thing that I need to do here, initially both my min heap and max heap are empty, right? So here let's point this my left to at this position. Okay, left at this index. Okay, so initially my left is at this 0th index. Okay, left boundary of the sliding window. Okay, so we are using the sliding window approach only, the simple, right? Every time I am incrementing left or the right. Okay, this is what's happening. So I am using the sliding window, right? So initially let's take my left is pointing to this 0th index, and my right is also pointing to this 0th index. Okay, and here in this box I am going to update my longest window size. Okay, longest window size. Okay, here let's suppose here I want to update. Okay, in this box. Okay, so initially both my min heap and max heap are empty. Okay, so here in this main heap, okay, first let's add, if I just my right pointer is at this position now, so let's offer this value to both my main heap and max heap initially. Okay, so what is the value? This value is 10 now, right? So here I am just writing 10. Okay, in main heap I am writing 10, and this value is present at which index? 0. Okay, so here I am writing this 0th index. I am writing both index and writing the both value. Okay, here in the max heap, okay, again add my what is the max value until now. Okay, initially my right is at this position now. If I just consider this element, okay, this is the only element available, so I have to add this. This is the only element, so I have to add this in both my min heap and max heap now. Initially both are empty, right? So here let me add the max element. Okay, so 10 and index 0. Okay, this is done. And now what is the absolute difference between my max heap value and min heap value? So 10 minus 10 is 0, and 0 is less than equal to my limit. Okay, 0 is less than equal to my limit is 5. Okay, so this is one valid window, right? So here I am going to update my longest to the 1. Okay, I am going to update my longest to the 1. Okay, this is done. So let me clear this. Okay, so I hope that this line is clear. Okay, so now after that my R is going to move forward. Okay, so let me clear this part. Now see carefully, my right moves to this position. Okay, my right moves to this position. Okay, add one index. Okay, so this is done. So let me remove it. This is done. Now see carefully, I am going to search in this particular window, right? In this particular window. Okay, so this one this is one value is 1. Okay, so let me add this one value in my min heap. Okay, in min heap my minimum element will go to the top, right? So here I am writing 1, and then this one is present at which index? 1 index. So here I am writing 1, and in my max heap this one value will come down here at this position, and at which index? 1. Okay, this is done. Okay, this is done. Okay, now what is the absolute difference between my max heap value and min heap value? 10 minus 1. Okay, 10 minus 1 value is 9, and 9 is greater than my limit. Okay, so this is not a valid window. Okay, this is not a valid window. So now what will happen? Okay, now see what will happen. So now my this left, okay, my left is going to move to this position. Okay, so I have problem with this this value now. This value is very large, right? And so only this pointer will move forward now. Okay, only this pointer will move forward, right? So now my left is going to move forward, okay, to this position. Okay, so what I need to do here, I need to remove this value. Okay, this value, okay, 0 10. Okay, from where? From max heap or from min heap? From max heap. Okay, so actually what we need to do here, since I have problem with this index now, I have the problem with the minimum value index. Okay, so what is the minimum value among these? Okay, this index is 1 and this index is 0. What is minimum among them? What is minimum among them? This value is minimum among them, right? And I have a problem with this. Okay, so my left is moving forward, right? So here what I have to do, I have to remove this 10 0. Okay, this 10 0 from my max heap. Okay, I have removed this value. Okay, I have removed this 10 0 from my max heap. Okay, so and my left pointer moves to the index 1, right? So here let me remove this. Okay, let me remove few things here. Okay, this is done. So now both my left and right points to 1. Okay, this is clear. Okay, so now see here, okay, this is done. So this is the only window now. Okay, and what is the difference between this 1 and 1? Okay, 1 minus 1, difference is 0, and 0 is less than equal to my limit. Okay, so here window size is 1 and longest is already 1. Okay, so I don't need to update it. Okay, so let me remove this part. This is done. Okay, so just note this point. Okay, this time I have removed the value from max heap. Okay, here I am writing removed value from max heap. Okay, just note this. Okay, just make a note of this item, RVMH, removed value from max heap. Okay, okay,
So now my R is going to move forward. Okay, my R is going to move forward. So let me remove this value. Okay, here, 1 second, this R. Okay, so now my R moves to this position, right? R moves to this position. Okay, so here I am writing R. Okay, so now I have to search in this particular window, right? In this particular window. Okay, and my R, since my R moves to this position, so I have to add the values. Okay, so 2, add 2. Okay, this is my min heap, right? So my 2 of 2 will come to this position, okay, in between. Okay, so let me do one thing here. Let me select this value and move it down. Okay, move it down, and okay, this is okay, 1 second, sorry. Okay, so now let me add 2 and 2. Okay, here, this is done, and in my max heap this value will come to the top. Okay, so here I am writing 2 comma 2. Okay, this is done. Now calculate the absolute difference between my max value and min value. Okay, so max value is 2, minimum value is 1, so 2 minus 1 is 1. Okay, 2 minus 1 is equal to 1, and 1 is less than equal to my limit, right? So definitely this is a one valid window. Okay, so I have to update my longest. Okay, what is the size of this longest? It's 2 now. How I'm going to calculate the size? So simple formula, right index minus left index plus 1. Okay, so right is 2, my left is 1 plus 1, so output is 1 plus 1 is equal to 2. Okay, so this is the formula, right minus left plus 1 will give me the longest window size. So here I have to update my longest to 2. Okay, so let me delete this part, this one, and here instead of this I have to write 2. Okay, this is the max window size. Okay, this is done. Now after that what will happen? After that my R is going to move forward, right? So here let me delete it, delete this, delete this. Now my R is going to move to this position. Okay, this is done. Now I have to check this particular window, okay, and this 4 is there now, this 4 is there, so I have to add 4 in my min heap and max heap. Okay, my every time whenever I am moving my right pointer, so I have to side by side add this R pointers value in my min heap and max heap. Okay, this is what I am doing. Okay, this is min heap, right? So minimum element should be on top, so this value 4 at 3 index will come before this 2. Okay, so let me do one thing here. Let me select this part, let me move this part to little top. Okay, this is, let me move this here. Okay, this is done. So now here I have to add 4 and 3. Okay, 4 at 3. Okay, and this is my max heap, so my 4 comma 3 will come here. Okay, right, and let me remove this part. Okay, so now see what is the minimum element of this window? 1, and see in my min heap it is directly giving me 1. Okay, just of one operation. Okay, just of one time complexity, it is already giving me the value, right? This one value. Okay, and what is the max element in the subarray? It is already giving me the top element of max heap. Okay, that is why I'm using this priority min heap and max heap. Otherwise I need to again search min heap and max heap, and it if I don't use this max heap and min heap, then I have to search the values by max value and min value, and it is going to increase my time complexity. So see, this is very helpful, right? Min heap and max heap. Okay, so in the top I get the max value, in the top of min I get the min value. So 4 minus 1 is equal to 3, and 3 is less than equal to my limit value is 5, right? So this is one valid window. Okay, so now what is the length of this valid window? Right minus left plus 1. 3 minus 1 is 2 plus 1 3. So here I have to update my longest to 3. Okay, so here I have to update my longest to 3. So let me erase this. Okay, and update it to 3. That's it. Okay, this is clear, right? Okay, this is clear. Now let me remove this. Okay, my R is going to move forward now. Okay, so now my R reaches to this position. Okay, and now see this window. Okay, now let's see this window. Okay, so since my R moves forward, so I have to add this 7 value in both my min heap and max heap, right? So this 7, okay, this 7 at index 4 will come at this position. Okay, 7 at index 4, this will come at this position in my main heap, and here it will go to this position. Okay, 7 comma 4. Okay, so now see carefully, and now you will see how why I was saying this. Okay, removed value max heap, why I have written here. Okay, so now first see this. So is this a valid window? So let's see. 7 is my max and my minimum is 1. So 7 minus 1 is equal to 6, and 6 is greater than my limit. So this is not a valid window. Okay, this is not a valid window. So now what? So now I have to move my left to the next position. Okay, I have to move my left to the next position here, and I have to remove these elements, right? I have to remove this element. Okay, my left is moved further, I have to remove this element. Okay, so first now tell me what is the minimum index. Okay, last time when we have used this RVMH, I have removed the minimum index. So this time tell me what is the minimum index. This is one index, this is one index. Out of this, which is minimum index? This is minimum index, right? This is minimum index. So I have to remove the value from min heap this time. Remove value from min heap this time. Min heap this time. Okay, so here I have to remove this value. Okay, since my left moves further, so I have to remove this value. Okay, so now I am just going to delete this. Okay, I am just going to delete this. Okay, this is done. So since my left move further, so I have to, let me delete it. So now this is the new window. Okay, this is the new window 247. Okay, so in this window this is valid. So 7 minus 2 is 5, and 5 is less than equal to my 5. Okay, 5 is less than equal to 5. So yes, this is valid. Okay, we are good. Okay, so window size again 4 minus 2 plus 1 is 3. So longest is already 3, so no need to update. Okay, so now what is going to happen? My R is going to move forward. Okay, my R is going to move forward. So now my R reaches to this position. Okay, my R reaches to this position. Okay, so is this a valid window? So see here. Okay, let me delete it. So max element, get it from max heap. Minimum element, get it from min heap. 7 minus 2 is equal to 5. Yes, 7 is the max and 2 is the minimum. Okay, no issues. So 5 is less than equal to my limit, right? So this is a valid window size, right? So now let me count the window size. Right is 5, left is 2 plus 1. 5 minus 2 is 3 plus 1 is equal to 4. So I have to update my longest as 4. Okay, so I have updated my longest as 4, and then after that my right is going to move out of bound. Okay, here at this index I have to stop. So what is the longest value that I get? Longest value is 4. Okay, and 4 is my output, right? So simple. Okay, so I hope that you guys are clear with this explanation. Okay, how this max heap and min heap is working here in this particular example. Okay, in this particular problem. Okay, so now let's write the same story whatever I have explained. Okay, let's move to the coding part. So first calculate the length of my nums array. Int n is equal to nums dot length. Okay, after calculating the length of my nums array, we have to use priority queue. Okay, min heap and max heap. So okay, so let's define that. Priority queue, and we are adding the values in pairs. One first thing is this is value and this is index. Okay, so let's add a int array here. Okay, with two values. Okay, so here int array, and here let's name it as max priority queue. Okay, max priority queue. Okay, let's name it as max priority queue. Okay, and okay, here write new priority queue. Okay, new priority queue, and here let's suppose there are two parameters. Okay, there are two parameters a and b. Okay, since this is a max heap, okay, so I have to write it like this. Okay, b of 0 minus, okay, max value will come first on top, right? A of 0. Okay, so this is going to be my order. Okay, so here let me write this as max heap. Okay, so now same way we have to define our main heap, right? So here just copy paste the same thing. Here instead of this max pq, let's name it as min pq, and here just change the order. Okay, if a and b two elements, then a of 0. Okay, we are comparing based on values now. Okay, so here let's suppose these two are values. Okay, these two are values. So here I am index 1 0. Okay, this is index 0, this is index 1. Okay, so I am comparing based on this index now. So that is why. Okay, so here this is a of 0 minus b of 0. Okay, so this is going to be my main heap. Okay, different order. Okay, this is done. Okay, this is clear. Then after that we have to set to the boundaries, right, for our sliding window. So same thing na, int left is equal to 0 in the starting. Okay, so initially my left is at 0, now somewhere here. Okay, I have erased that. Okay, initially my left was 0 and my right was also 0, and longest value is equal to 0 initially. Okay, then I have to run one while loop na, while my right is less than n. Okay, every time I am moving my right. Okay, every time I am moving right one step forward. Okay, while my right is less than n. Okay, so initially both my min heap and max heap both are empty, right? So initially just offer the values. Okay, so max what is the name, max pq. Okay, max pq dot offer, and in this offer I am adding array values, right? So here new int, and what is my first value of my array? First value of my array is value now. So here can I write it like this, nums of, right? And my second value that I am passing is index. So right. Okay, so see here every time I am adding the values, right? So 10 0 when I have added this, so 10 is my value and 0 is my index. Okay, so that is what I am writing here. Same way, this is I am adding this in my max priority queue, and I have to add the same thing in my min priority queue, right? So just change the name. Okay, min pq. Okay, so in max pq the maximum value will come to the top, in min pq the minimum value will go to the top. Okay, this is done now. Okay, so in which case I am moving my left forward? In which case I am moving my left forward? In which case I am moving my left forward? Only when the value between absolute value difference is greater than limit. Now only in that case I am moving my left forward, right? So let's write the same thing here. So while max pq dot peak, okay, dot peak, and value is stored at index 0 now. So here I am writing 0. Okay, minus min priority queue, okay, dot peak, and here at which index I am storing values, 0th index. Okay, if the difference is greater than a limit, right, then in that case only I am moving my left forward. Okay, in that case only I am moving my left right. So how many left how I am moving this left? Okay, so left I am moving only for the only where my index value, okay, is smaller. Okay, out of main heap and max heap, wherever my value is smaller, I am moving my left. Okay, so here my left, okay, I have to write it like this, math dot min, okay, whatever minimum between the index of max dot peak at index, this is 1 at index 1, this column. Okay, this is 0th, this is 0, this is 1, right? So max here max pq dot peak 1, and here min, just copy this and let's rename it to min pq dot peak 1. Okay, this is done, and I am moving my left to one next position now, to one next position. So here after that just add 1. Okay, this is done. Okay, so see here, this is not a valid window, so my left is moving from index 0 to 1 na? Index 0 to 1. Okay, so what I did, I first find the minimum value na. What is minimum value? This 0 is minimum or 1 is minimum? So 0 is minimum, so in this 0 I have added 1. Okay, this is what I am doing, right? What is the value, what value is the minimum? Okay, whatever the value is minimum, and in that minimum value I am adding 1. Okay, this is how my left is moving forward. Okay, so this is what's happening here. Okay, so first I have to find the minimum between my max priority queue top element, top index, and min priority queue top index, and after finding the minimum I am just incrementing the 1 na. Okay, so whatever, okay, so see, this is one value, this is one value. Okay, this is index 2 and this is index 4. Okay, and in one place this is index 4 and this is index 2. Okay, so I have to move to 3 only now. So out of this, which is minimum? 2 is minimum, so here I am adding 1. Out of these 2, which is minimum? This is minimum, so here I am adding 1 and moving to 3. Okay, this is what's happening. Okay, simple way. Okay, so this is what's happening here. Okay, so I hope that this line is clear. Now here, this is where I have updated my left. Okay, so now after that I have to run one more while loop, and in this while loop I have to check if my this max priority queue is not empty. Okay, it's not empty. Okay, and max pq dot peak at 1. Okay, this index, okay, this is less than my left index. Okay, this is left index. Okay, then in that case I have to just poll the elements. Okay, max pq dot poll. Okay, same way in case of min q. Okay, same way, same thing, we have to write it for min q as well. So just copy paste here, instead of max just write min, and here same min. Okay, and here write min. Okay, so see here why I am writing these two lines here. So simple reason is that, let's suppose there is one array like this now. So let's suppose this value is 2 1 4 6 7, and right now, and here so on. So right now let's suppose that my left pointer is at this position and my right pointer is at this position, and this is one, let's say this is my min heap and this is my max heap. Okay, so here in my max heap, let's name the index as this 0th index, 1 index, 2 index, 3 index, 4 index, right? So in my max heap, the maximum value that I have stored here is 7, and this index is 4, and in min heap the minimum value is 1, and this is stored at index 1, and after that 1, this 2 value is there, right? 2 0, and after this this value is there, right? 4 at 2 index, and after that this value is there, let's say that 6 at 3 index. Okay, so here let's suppose this is 7 and this one, right now difference is 6, and let's suppose that this 6 is greater than my limit. Okay, so this is not one valid window. Okay, if this is not my valid window, then I'm taking left as math.min of the peak. Okay, but is minimum between them. So minimum value between them is 1 or 4. What is minimum? This is minimum, so I have to remove this one. So my left is directly jumping to this position now. From this, my left is directly jumping to this position, right? So if my this left is directly jumping from this to this position, so I have to delete these two indexes as well. Now I have to delete this, I have to delete this as well, right? Because now my window is shrink to this part. Now I have to remove the previous indexes. Okay, all these indexes, since my left is directly jumping to this position, right? right? So this is the only reason that I am writing this while my max priority queue is not empty. Okay, so this is my main now, so this condition will work. Okay, this is not empty and this dot peak value is less than left. Okay, so this one is left than left, 2 left value is 2 now this 0 is left than 2. Okay, so I have to delete this. Okay, main pq dot code. Okay, so that is the simple reason that I am writing this. Okay, and in the end, after running this while loop, we have to just update our longest update longest with the length of the current valid window, right? So here I have to update my longest as math dot max between my longest, and here how I'm calculating right minus left plus 1. This is how I'm calculating, right? So this is my longest, and every time I'm incrementing my right one pointer ahead every time. Okay, so this is done. Okay, so here my while loops end, and in the end we have to just return the longest. That's it, return longest. Okay, so now let's run the code and see if there are any code issues. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And what is going to be my time complexity for this problem? It is going to be of n into log n. Why it is going to be of n into log n? So since we are using the priority queue now, and in priority queue whenever we are adding the elements, so it is going to take log of n time complexity. Okay, whenever we are using the peak operation, it is going to take of 1 time complexity. Whenever we are using this pole in priority queue, it is going to take off log n time complexity. Okay, and overall my right is moving one by one every time. Okay, iterating over all the elements. So here it is taking off n. So overall I can say that of n into of log n. Okay, for all these operations. So my overall time complexity is going to be of n into log n. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.